Alright, this is lesson 24 on surface area of solids. It is based on a skill from 6th grade. It states that in 6th grade you learn to use nets to represent rectangular prisms. In this lesson you will learn to find surface area of rectangular prisms and other right prisms. We want to find the surface area of the building block in Ben's construction set shown below. So what we see here in this picture is the net that matches the three-dimensional shape that represents Ben's construction block. We have corresponding sides of top and bottom. We have side and side, front and back. Now you can take the same three-dimensional figure and then label the sides accordingly with their number that matches. Doing this allows us to see the 2D figure and how you'll get its overall area. So when we look at the bottom is covered by the 1 and the 4. So 1 is here and 4 is here. So that means that every side that corresponds with that 4 will also be a 4 for this side and for the top, and for this side as well. That also means that the front has a 1 here and the back has a 1 here. So we're placing the measurements where they belong now. When we look at the side we've already covered with the 4, but we have to figure out the other measurement that goes with it. And the side is here. So that is 2 and 4, which means that this portion is 2, this portion is 2, this portion is 2, and this portion is 2. When you look at the top corresponds with the bottom, so the only measurement that we've left off of the top is the 1 and the 1 here. We still have left to fill in about the front and the back. We have our 1s, but we have to identify the second measure. And the second measure comes from the fact that this portion is the front, and that was 1 by 2. So it was 1 wide and 2 high. Same for the back, 1 wide and 2 high. So we've now filled in all of the numbers that represent all 6 sides of that three-dimensional figure, and we can find the individual areas to add together and get the surface area. Those are the things that we're going to think about as we answer the Explore It question. We're going to make connections about how the net represents this three-dimensional figure in order to get the overall surface area. So as we explore it, the first question that we're asked is how many faces does the block have? And we've already answered that. We said it has how many?
6.
There are 6 faces. And we need to know what shape are all 6 of those faces.
Rectangle.
We're then asked to draw the top and bottom faces and label their dimensions. We can refer back to the original picture or we can refer back to the net that we created. But the top and bottom were both skinny rectangles. And the top and bottom both have corresponding measures. So the short side of the top was 1 and the long side of the top was 4, and the bottom was 1 by 4 as well. So we drew the top and the bottom and we labeled the dimensions as 1 and 4. Overall, we're trying to find surface area. So these are 2 surfaces and we can get their area. The area is the length times the width, which means that we will do 1 times 4, which means that this is 4 for the area. Again, for the bottom, it would be the same. Area is length times width, which is 1 times 4, or 4. Now, what unit of measure do we have in this problem? Inches. So because we're dealing with area, which is of a two-dimensional shape, these are both 4 inches squared. Next, we're asked to draw the front and back faces of the block and label their dimensions. Now, the front and back, we said that they were both skinny rectangles, but they weren't very tall. And they were 1 on the bottom by 2 on the side. 1 on the bottom by 2 on the side. Again, we're looking for surface area. And area is length times width. So 1 times 2, which is 2. And it'll be the same for the back as it is for the front. So again, 1 times 2, which is 2. And we have inches. We're talking about area, which is taken of a two-dimensional figure. So 2 inches squared. 2 inches squared. Then we want to draw the side faces and label their dimensions. The side faces were rectangles as we normally see them. And their measures were 4 by 2. And they were the same for both sides since this is a right prism. And again, to find area, that is length times width. So this would be 4 times 2, which is 8. And 4 times 2, which is 8. Again, area is taken of a two-dimensional shape. And we're measuring in inches, so inches squared. Inches squared. So we now have 6 sides areas. 4 inches squared, 4 inches squared, 2 inches squared, 2 inches squared, 8 inches squared, and 8 inches squared. We've covered all 6 sides. So when it says, how could you find the surface area of the block, you would take all 6 sides and add them together. So you'll add the area of all 6 sides, which in this case would be 4 plus 4 plus 2 plus 2 plus 8 and plus 8. 4 and 4 gives us 8, plus 2 is 10, plus 2 is 12, plus 8 is 20, and plus 8 is 28. So 28 inches squared. Alright, so now if we want to find out more about this, it's going to explain to us what we did when we found that surface area. So the surface area of a three-dimensional figure is the sum of the areas of all of its faces. So as you're finding surface area, you need to be adding all of the areas of all of the faces, because that's what it means to find the sum, is to add all of the areas. It says that a rectangular prism has 3 pairs of faces that are the same size and shape. The bottom and the top have the same area, and we're finding the bottom and the top by doing length times width. Then it says that the front and the back have the same area, and that area can be found by doing height times width. The left and right side faces have the same area. That can be done by doing the area is the height times the length. And that's just if you're looking at it as its three-dimensional shape and trying to make sure that you account for all 6 sides. So to find the surface area of a rectangular prism, you add the areas of all 6 faces, which means that the surface area is length times width plus length times width, which covers the top and the bottom. Then you'll add it to height times width plus height times width, which covers the front and the back. Then height times length plus height times length, which covers the left and right side. Or if you were to condense that, like we did when we found equivalent expressions, that is 2 times the length times the width, plus 2 times the height times the width, plus 2 times the height times the length. I personally find it confusing to try to remember that formula, so I resort back to the picture and the individual shapes. I personally draw it out and label the individual pieces and remember to get the areas. So that way you don't have to remember the difference between L and W and H and W and make sure that you've covered everything. So now we're going to look at this problem and reflect. As we reflect, it says, how can you find the surface area of a cube with edge lengths of 3 inches? I'd like for you to do that now. So as we think about a cube that has an 3-inch side length, a cube is special because all of the side lengths are going to be the same because it's made up of squares. So you can take one side of that cube and find its area, and then multiply it by 6 in order to get the total. So 54 inches squared is the total surface area in this case. This is what you can do for a cube, but you can only use this method for a cube. You never could for a rectangular prism. But every cube is also a rectangular prism. So if you treated it as a rectangular prism, you would do 3 by 3 for each side, for the front, for the bottom, for the side. You can multiply that by 2 to account for the front and the back, the bottom and the top, and both sides, which means overall 3 times 3 is 9, and 9 times 2 is 18. So you would be adding 18 3 times, which would still give you 54 inches squared. So there's multiple ways to go about getting the area here. The easiest in this case for a cube is find the area of one side and then multiply by all 6 sides. We next want to read the problem below, then explore different ways to calculate the surface area of a triangular prism. How many square feet of nylon fabric would be needed to make the camping tent shown below? So let's start the same way that we did as the last problem, where we kind of think about what the net of this picture might look like. That's going to allow us to make sure we know the dimensions for all of the sides involved. So please draw your net now. As we draw the net, it oftentimes helps to think about what face you think it's sitting on. And when I look at that picture, I see it sitting on a rectangle. And then from that rectangle, I have 2 more rectangles that are the sides. And again, from the rectangle that it was sitting on, 2 triangles that fold up to make the front and the back. So your net should look something like this. And as you go about labeling the information, you need to think about which piece of that you're labeling at that time. So if you start with that bottom piece, that initial piece that was drawn, it is 8 feet by 6 feet, which means all the way around it, you have 6, 8, 6, 8. That also tells you that this side here is 8 and this side is 8. Now, if you think about that triangle, because it might be the easiest piece to see next, the slanted sides that come together to make your triangle are both 5 feet. Because when you bring those sides up to meet your triangle, they're going to connect with this 5. That means that this side will also be 5. And this side will also be 5. And the back is going to be the same as the front. So the slanted sides of these triangles are going to be 5. As they fold up, these 5s will connect here and here. We almost have enough information to get all of the areas, but we're missing the height of our triangles because the height of the triangle has to connect at a right angle with the base. So your height will be here, and that height is 4 feet. And again, as it is for the back, it'll be the same for the front. Now we have all of the measures that we need, and we have more numbers written than what we need, but we know that we haven't left anything off. All right, now we look at the picture it. We've just done that for ourselves by creating a net. In this picture it, they actually have you think about the different shapes as individuals. So it says you can draw and label the dimensions of the 5 faces of this prism. The tent is in the shape of a right triangular prism. So the bases of the prism are 2 triangles that are the same size and shape. And they've drawn those 2 triangles and labeled the dimensions, just as we did. The other faces of the prisms are 3 rectangles. 2 of the rectangles are the same with measures of 5 by 8. And 1 of the rectangles is different with measures of 6 by 8. It says when you solve it, that you can find the area of a rectangle with the length and the width by finding the length times the width, and the area of a triangle with base and height, where area is 1/2 of the base times the height. Now we looked at both of these formulas, but we tend to refer to the area formula of a triangle as base times height divided by 2. And they say the exact same thing, so this is kind of personal preference in what you want to do. Now we're going to make some connections about what we just did with that problem. It says, how can you find the area of the faces of the prism? The faces are 2 shapes that we know the area formula for. So you're going to find the areas of the 2 triangles. And you'll do that by using base times height divided by 2, or 1/2 of the base times the height. And of the rectangles, and of the 3 rectangles, using the formula length times width. You have to be careful to split the shapes up appropriately first. Do you have to find the areas of 5 different figures and explain your thinking? What do you think, yes or no? No. There are 2 triangles that are the same. So 2 triangles have the same area. And even 2 rectangles have the same area. So you only need to find the area of 3 different figures. What is the area of the triangular base? And show your work. The triangular base was a base of 6 and a height of 4. So we do 6 times 4 and divide that by 2, which gives us 24 divided by 2, which is 12. What unit of measure did we have? Was it feet? So that's 12 feet squared. We have two triangular bases, so we can take that 12 and multiply it by 2 to get both, which means that both triangular bases cover 24 feet squared. It asks what are the areas of the rectangular faces and show your work. We had two rectangles that were 5 by 8. So one of them is 40 feet squared. We could again multiply that by 2 to cover both of them that are 5 by 8, meaning that they cover 80 feet squared. And the last rectangle was 6 by 8. So it covers 48 feet squared. So if we want to find the surface area of the tent, you'll take the three measures that we just found, the 24 feet squared, the 80 feet squared, and the 48 feet squared, and you'll add them together because this is adding the areas of all of the sides. So adding the areas of all of the sides. Will give you the surface area. So if you use your own words to explain how to find the surface area of a right triangular prism, you might say that you add the areas of each side of the figure together, and that will give you the surface area.